Section 7.2, Inverse Functions and Relations. Inverse relations. Two relations are inverse relations if and only if, whenever one relation contains the element a comma b, the other relation contains the element b comma a. Property of inverse functions. Suppose f and f inverse are inverse functions, then f of a is equal to b if and only if f inverse of b is equal to a. The notation that we see here with f and then that -1, which looks like an exponent, speaks to what we call the inverse function. Okay, so inverse function, or f inverse of x, as we'll see later. Example, find the inverse of the function f of x equals 2/5 x minus 1/5. Then graph the function and its inverse. So the first step in this particular process is to replace f of x with y in the original equation. So your equation becomes y equals 2/5 x minus 1/5. Step 2, interchange x and y. So as we see here, we take that equation and simply take x and y and just switch so that x equals 2/5 y minus 1/5. Last step, solve for y. Taking this equation, we can multiply both sides by 5, as I'll show here. Okay, and in the next step you can see that 5 times x, 5x, 5 times 2/5 y, just 2y, 5 times -1/5, -1. So 5x equals 2y minus 1. We'll go ahead and add 1 to both sides. So 5x plus 1 equals 2y. And then last, divide by 2. We divide everything by 2. And what they show here is quite okay with 1/2 times that quantity, 5x plus 1 equals y. Now I will actually go ahead and show both varieties, noting y equals f of inverse of x, which equals 5/2 x plus 1/2. This is a good final answer for the inverse, f inverse of x. They also note here, right here, that f inverse of x can also be equal to that, and I would be okay with both of those results. But let's take a look at the graph. So the graph is done for you. F of x here, 2/5 x minus 1/5. There is, for that particular line, a y-intercept of -1/5. And the slope from that point, 2/5, so I'm going to go up 2, right 5, putting me here. Okay. The other line, the inverse function that I just came up with, has a y-intercept of 1/2. And then the slope from there is 5/2, so up 5, 1, 2, 3, 4, 5, and then right 2, which will probably take me off the graph there a little bit, but there we go with that line. Okay, so we've got our two functions, f of x and f inverse of x. Now, when it comes to how these two functions graphically interact, we can draw in a third function. This third function, most often than not, you're going to have to draw it in on your own, noting the equation here, y equals x. And I'm going to go ahead and call this, quote unquote, the axis of symmetry. If you recall back in the section with quadratics and graphing parabolas, the axis of symmetry is the line that divides the parabola in half, where if you pick a point on one side of the parabola that's equidistant from the axis of symmetry, a point on the other side, again equidistant, will have the same y value. And that is the same with these points here on the blue function graph, we'll say, or f inverse, as well as the red function graph, f of x. So how can we justify these facts, though? Well, let's go ahead and make an xy table for f of x Let's make an xy table for f inverse of x. And I'm going to pick some pretty simple values here. Picking -1, 0, and 1 for the f of x. And let's see what we end up with. Plugging in -1 will give us -2/5. So we have -2/5 minus 1/5. So that's -3/5. Plugging in 0. Well, that will give us 0 times 2/5, 0, and then -1/5. Plugging in 1, 2/5 minus 1/5, 1/5. Okay, I tend to like picking 3 points, although you don't need to graph this line, you don't need 3 points, either of these two. But 3 points are nice when justifying what I'm about to justify relating to the inverse. So we have a negative value, 0, and a positive value that we're plugging in. Okay. What I'm going to go ahead and do to make things interesting here is I'm going to actually plug in on the other function now, -3/5, -1/5, positive 1/5. Watch what happens. So we're going to plug in -3/5 right there for x into the f inverse of x function. So 5/2 times -3/5. And maybe what I'll do is just jot this one down to start with. So 5/2 times -3/5 plus 1/2. The 5's will cancel, leaving us with -3/2 plus 1/2. Which if we add the two, because the denominators are the same, we take the numerators and end up with -2/2, and that simplifies to -1. There is a connection to the other function. I chose -3/5 for a reason, and as we can see, the x-coordinate of f of x is now the y-coordinate of f inverse of x. And the same will happen with the other two values. In other words, -1/5, 0, 1/5, 1. Now if we look at our graph, well, -1, -3/5 for the f of x. Just quickly confirm that, which is right here. 0, -1/5, we already have plotted, and then 1, 1/5, which would be roughly there. Okay. Switching the x and y's, therefore points on the other function, -3/5, -1, -1/5, 0, and then 1/5, 1, which is here. Okay. Ladies and gentlemen, we have just proven that the x and y values of each respective function are just simply switched. And as we can also see graphically, there is some symmetry at play here, where, for example, taking this ordered pair, reflecting it about that axis of symmetry, it lands over here. Okay, so let's continue. Exercises. So find the inverse of each function, and then graph the function and its inverse, starting with number 1. So f of x equals 2/3 x minus 1. So the steps are as follows. We change f of x to y, so y equals 2/3 x minus 1. And then we switch x and y, so x equals 2/3 y minus 1. And then we solve for y, adding 1. So we've got x plus 1 equals 2/3 y. And then I want to get y by itself. So what I'll do here is actually multiply by the reciprocal of 2/3. In other words, 3/2. And that will then lead to, and I'll distribute the 3/2. So 3/2 x plus 3/2 equals y. And I'll write that just like the last problem, f inverse of x. So there's my inverse. Okay. So it does say graph, so let's graph the first function. F of x equals 2/3 x minus 1. So that will have a y-intercept of -1. Slope is 2/3, so up 2, right 3 puts me here. And I can graph that line. The other function, the inverse function. Y-intercept is 3/2, so there's 3/2, or 1.5. The slope is 3 over 2, so 1, 2, 3, and then 2 to the right. 3 up, 2 to the right. Here's your function. And there you have it. I am again going to draw the quote-unquote axis of symmetry. It's a term that I implement here to help kids understand that there is a relationship between the points that are equidistant from that axis of symmetry. So, for example, let's pick this point on the blue function. Okay, so this point is 0, 3 halves. If you reflect that point about that axis of symmetry, 3 halves, 0 is on the red function. So again, 0, 3 halves reflected over becomes 3 halves, 0. Let's move on to number 3. Number 3, again, find the inverse. So the first step, rewrite the problem so that y equals 1/4 x minus 2. Switch x and y in our next step, like that. Add 2 to both sides, and then we have x plus 2 equals 1/4 y. From here, if I multiply both sides by the reciprocal of 1/4, which is 4, and then simplify in the next step, distributing the 4, so 4x plus 8 equals y, or f inverse of x. There's my inverse. We're going to go ahead and graph both. The first function again, y equals, or f of x equals, same thing, 1/4 x minus 2. So we'll put a y-intercept there at -2, up 1, right 4, that is my slope. Here's your original f of x function graph. The inverse function has a y-intercept of 8, so I'm going to have to go off the graph. 1, 2, 3, 4, 5, 6, 7, 8. That y-intercept is there. The slope is 4, and I could go up 4, right 1, but I think I'll opt to go down 4, left 1 instead for the sake of space. 1, 2, 3, 4, and then left 1. Again, just to note that the slope being 4 over 1 can be written as -4 over -1. So down 4, left 1 is just as good here. So we've got our line now through those 2 points, and those are my 2 inverses. Yet again, I will finish this off with the line y equals x. This line is our quote-unquote axis of symmetry and provides that symmetric relationship between x and y values on each respective function. Let's take a look at the next page. Verifying inverses. Inverse functions. 2 functions, f of x and g of x, are inverse functions if and only if f of g of x and g of f of x both equal x. Now I'm going to go ahead and rewrite this so that we can easily relate it back to something we've seen before as follows. So, as we see, f of g of x and g of f of x in the common notation equals x. If they both equal x, then we know they're inverses of one another. And we will have to prove that both of them equal x. In the first example, determine whether f of x equals 2x minus 7 and g of x equals 1/2 times the quantity x plus 7 are inverse functions. So we start with f of g of x. Substituting g of x, 1/2 quantity x plus 7, in for x into the f function is what we'll do here. So we'll take this 1/2 times the quantity x plus 7, substitute it in for x, so 2 times that quantity minus 7, and then do our math from there. 2 times 1/2, that's nicely just 1. So we're left with x plus 7 minus 7. That's nicely going to cancel. Therefore, you do end up with just x. So we've verified half of what we have to verify.